So one of the things we referred to earlier as kind of a large-scale challenge for our region is thinking about how to adapt and mitigate to climate change and some of the already inevitable consequences of that, including some level of sea level rise. And so there's a lot of different ways to think about this question of climate change, sea level rise, and how to frame what that means to you and how to think about it. But I think one framing statement that's simple, I think, to capture all of this is, how try to think about the goal of how do you make your resources resilient to changes and impacts caused by climate change. So I think that's a pretty simple statement, but I think there's also a lot to unpack there and some definitions to think about. So first is thinking about what are your resources? What are the resources that you care about? That could be many things, as we talked about earlier. It could be your house or your beach or something like that, or the wildlife habitat. We also want to think about what the potential changes and impacts are in your area. Our shorelines are diverse, and depending on your topography and location and microclimate and things like that, the potential impacts to you or changes you might see on the ground are going to be different than other areas of Puget Sound or even perhaps other areas of Mason County. And then we also want to think about what the actual risk is of these changes. What is the likelihood and time scale, potential magnitude of some of these changes and impacts? So let's follow that train of thought and break that down a bit. So what are your resources? Like we talked about, it might be your beach access, it might be the wildlife habitat, it might be your infrastructure, including your house, as well as your patio and your septic and your well system and all of that, and your boating access. And so that's a lot to think about in terms of how to protect that and make that resilient to potential changes to climate change. And so as I mentioned earlier, we're going to see warmer seasons, warmer temperatures on average. We're already seeing warm summers and high water temperatures and low water quantities in some of our streams. I think we traditionally think of Mason County and Puget Sound as a very wet area, but there are already some stresses in the summer for our fish, for instance, and water quality, and water quantity. And so those things are going to be increasingly challenged with the combination of more development and more climate change and the changing window of precipitation. So we may or may not see total annual average precipitation change, but we are pretty likely to see wetter winters but drier summers. We're also going to potentially see changes in our peak storm flows. So our freshwater systems are going to get a little flashier potentially in the winters. We're going to see more aggravated, bigger floods, perhaps more intense flooding. And we're also going to get more coastal flooding too, with rising sea levels and higher tides. And the new storms, may or may not be more frequent, but the storms that do come will probably be more intense. And the tides that are coming, the new king tides are going to be higher, the new higher water levels. It's going to be a new normal shifting baseline of what those tides are, even the low tides. So in terms of what we should expect with sea level rise, there's a lot of models about climate change and sea level rise out there, and it's important to do due diligence to consult different types of models. This is one example of looking at what sea level rise might look like. While there is a lot of uncertainty and variance, that doesn't mean we can't say anything about what we might know about this. So one way to interpret this chart with all the lines and numbers is that there's a 50% chance by 2100 that there'll be more than 2 feet of sea level rise across Washington state on average. And this is under a high emission scenario, assuming that we don't pursue any kind of aggressive climate change action soon and we continue with a path with pretty high emissions. So another way to look at that is also another local model by the University of Washington Climate Impacts Group. You can find that on this website, the WashingtonCoastalNetwork.com. It's a great resource. It's pretty fun. You can click on a certain area of Mason County, for instance. You can click on Harstein Island or parts of it. Or in this case, I tried to select a large region that covers Oakland Bay, Hammersley Inlet, and part of Totten Inlet there. And it will spit out different sea level rise projections. And so this is relative sea level rise, which means that accounts for some of the movement of land too. So although we're having rising sea levels, we're also having, due to the tectonics processes and geologic processes in the area, we're getting uplift in some areas, perhaps in like the Northern Olympics, and subsidence in other areas such as lower Puget Sound. And so, you know, the level of land is changing in addition to the changing sea levels. So those things together create a metric that we call the relative sea level rise. So again, there's a lot of numbers and lines in here, and so I know it's a lot to look at, but essentially this is all this is spewing out is a set of likely impacts under a high emission scenario and a low emission scenario. And the low emission scenario would be, you know, we get our act together, we pursue aggressive climate change policy, lower our emissions nationally and locally and statewide relatively soon, but we'll still see some lag time for those policies to take effect. And so just reading this chart again, it's a lot of numbers, but just one way to zoom in on that and take a look at what's the most conservative scenario. So the most conservative scenario would be under a low emission scenario, look what's the 99% chance likelihood of what we'll see under a low emission scenario. So this is kind of a best case scenario, sort of, right? So there's a 99% chance that we'll still see half a foot of sea level rise by 2100. On the other end, if we look at the most liberal scenario, what is the highest chance that we'll get the most extreme case? And so there's a 1% chance that we might see as much as 5 feet or more by 2100 under the high emission scenario. So, you know, there's different ways to break this down and look at it and project it, but another way to bring this a little closer to home is, you know, I know that's a big range, is to think about, you know, well, okay, fine, what's going to happen in the next 10 years? And interestingly enough, because of the potential lag time for any kind of emissions reductions at this current rate, or, you know, based on assumptions in the model, in the next 10 years or so, we're still likely to get almost half a foot, you know, 0.4 feet. There's a 50% chance under both scenarios that we'll get almost half a foot of sea level rise in Mason County. And so half a foot, you know, that maybe doesn't sound like a lot on its face, but if you live on a particularly low gradient shoreline, or, you know, even if you live on a higher bluff, you know, we're going to also see associated impacts with that. So it's not just that the sea levels will rise, it's just that the high tides will be higher, the king tides will be higher, the storm surge will be higher, you know, so you're going to have more complicated impacts than just the level, the net level of sea level rise. There's a lot that comes with that. So hopefully that makes sense, and if you have any questions, we can come back to that. And we're happy to talk through how sea level rise might impact your property in particular, and zoom in on a local area for you and help you interpret some of these graphs and charts and projections and models. So there's a lot of potential impacts caused by climate change, sea level rise, like we talked about, and it's going to be different in different areas. For instance, erosion and deposition. In a lot of areas, we're going to have more flooding and higher sea level rise, and that's going to cause more erosion and take away shoreline materials, and however, and have some loss of beach and so on. But in some cases, depending on your shore form, like we talked about the accretionary shore forms earlier, you might actually see growth. We're getting more erosion of that shore form, but then some of that will be deposited into an accretionary area. So this is what I was saying before. It really depends on what are the actual risk impacts and changes you might actually see in your area, which may differ from another area. But collectively, we still are going to see a lot of changes that will affect us probably pretty universally. So one of those is coastal flooding. Like I mentioned, we're going to have higher tides. The storm surge is going to be higher. The storms are going to be more intense when they come. We're also going to get greater freshwater flooding probably as well, due to the window of precipitation becoming more concentrated, as we talked about. Another thing is salinity changes. So this is a little bit of more of an invisible force. But rising sea levels also can have a feedback and impact with higher groundwater levels. Those can interact and help raise the groundwater levels, and that can in turn impact the salinity of, let's say you have a well or septic system near your shoreline. And so again, that's sort of like an invisible force that we might not see directly, but is perhaps happening beneath us over time. And so that's important to be thinking about as well, and not just the proximity of your house to the shoreline and erosion problems, but your other infrastructure. Another thing to be thinking about is habitat loss. Rising sea levels are going to reduce especially if they occur very quickly, it's going to reduce the capacity for those habitats to adapt and migrate up the shoreline. especially if there's bulkheads or in some cases steep bluffs, that can cut off the pathway in that transition zone for creatures and plants and habitats to migrate and interact across that gradient. So another way to look at this is a similar diagram we showed earlier in the presentation, this concept called the coastal squeeze, where basically, we're squeezing out that habitat. So on the column on the left, you can see what happens where we have a nice natural shoreline with the current sea level. We look below, okay, bulkhead. There's a bulkhead there that shows that during high tides, habitat is lost above mean high water due to that armor there. That armor is kind of blocking the habitat under high tides. So, however, if you put with future sea level rise, that habitat can shift upslope a bit. That can sort of translate. However, the bulkhead and sea level rise, that habitat's going to be lost entirely. So that's just something to think about as we think about all these trends together and interacting, and then also thinking about what we can do on our shorelines to manage them effectively for all sorts of resources that we're talking about.
Hey,
so go ahead.
Could I jump in there? Could we look at that diagram
Please.
again? So
Please,
we had a question. Yeah, we had a question about when advocating for alternatives to hard armor, how do you address concerns about sea level rise? So I just thought one way to think about that is that if you have a bulkhead and sea levels are rising, you probably often already see overtopping and a little bit of erosion behind that bulkhead. And so as sea level rises, you'll get more erosion behind the bulkhead and you'll lose those sediments, and your bulkhead will probably fail and fall on the beach. But if you have removed the bulkhead and installed something like we saw where there's the reslope and vegetated slope with well-established root systems, as sea levels rise, the plants that are encountering the saltwater, it'll happen slowly over time, and the communities that are in those areas will be able to adapt over time. And so you've got this root system that's holding your soils in place instead of just a rock wall or bulkhead that is a fixed and static height and can experience increased erosion because of the dynamics of waves overtopping them and stuff. So that's how I would argue that soft shore is a more adaptable way to address erosion along your shoreline.
Thank you for that question. Thank you, Katrinka, for the thoughtful response. Yeah, we can revisit questions about that in a minute as well. But just the thinking long-term and near-term about how to mitigate your risk, again, it's going to depend on definitions of what your resources are, what to what. When you think about your resources in terms of what changes we might expect. And so that may require some, site-specific assessment in that case. Most of the recommendations today are designed to make your property more resilient to environmental changes in general. So, although we didn't talk about climate resilience very specifically earlier in the presentation, as Katrinka mentioned, a lot of the things that we've been talking about today, managing your drainage, managing erosion, all those are in part to address upland development, impacts caused by upland development. There are also impacts that can help make your property, make the habitat, the vegetation, and in some cases your erosion risk and protection of the property more resilient to changes brought by climate change. And so it's really important to be thinking holistically about all the types of changes we can think about in our property, and almost all of those have some kind of interface with planning and thinking about climate change. And we're happy to talk through with you on a personal level what those concerns are and how to manage them. And in general, like we've talked about, pursuing more natural solutions can often be a solution that will help manage your risk the best and often can be more cost effective. So managing that drainage, managing vegetation, adding native vegetation, keeping the vegetation you have can be a simple solution in a lot of cases. In some cases, simple bulkhead, it's not a simple process, but bulkhead removal can be an important idea, and we can connect you with significant financial resources for those. That's a big driver of the funding for some of our programs. Up to you what your options are, but we're happy to help pursue that path with you if you're interested. And then In addition, where needed as a replacement for a bulkhead or alternative to a bulkhead, if you can't just sort of leave it afterwards, there are some of these soft shore alternatives like beach nourishment and so on that Katrinka referenced earlier in the presentation in the soft shore section. So just to recap, we offer a wide variety of technical assistance. We can help come out on site and talk you through with what's important for you with your resources and come up with plans to help protect them and manage them sustainably. We can help do some analysis and research and help write some technical reports for you. We can help develop some planting plans specific to your site if that's something you're interested in. And on some of the more technical work like the soft shore stabilization projects, especially Katrinka can help with some of that engineering work. We also have access to some people smarter than us, some geologists we're hoping to get on retainer, and some other folks, other partners in the area that can help you with permitting questions or more serious erosion issues, that sort of thing. We also have a lot of great resources on our website that we'd love to point you to. And we'd love to come out, talk to your HOA or your neighborhood or do a beach walk, something like that. We're still trying to figure out what those logistics might be with the current public health situation. So we want to be sensitive to what our management requires of us, as well as what the public is comfortable with. So that can be a conversation. You can be in touch with us if that's something you're interested in. I know at least one person on the call today. We've been in communication about that opportunity, and we're excited to work with you. And then also we connect you to a lot of grant funding resources, of course, for all of these, which, does have some uncertainty with the current funding climate, but we're happy to try to help advocate for good projects for you, some of our public funding sources. So just a reminder that, with or without climate change, your shoreline has been changing forever. Whether it's the last ice age and the glaciation that's created the shore forms that we've seen today, whether that's kind of thing on the medium term, on the scale of 10, 20, 30 years of development of large shore form features like the sand spit that we talked about, or whether that's things that are happening on a continual minute to minute, day by day basis, like the evolution of your shoreline as sediment is moving around and different processes are occurring that are shaping your shoreline. And so, your shoreline dynamics is always changing. It's going to continue to change with climate change, and many of the things we talked about today can try to help address some of the challenges and provide opportunities to help you better steward your shoreline. And your shoreline's always changing, and that's often okay. The messiness is complexity, and that often gives a lot of life, and working with nature is often the best. And so, it's your shoreline, your legacy, and we know that you are the experts on your property and what your vision for that is, and we just want to be there to be a resource for you and help you plan what that legacy looks like and try to help you manage your natural resources in a sustainable way. So thank you so much for your time today and showing up, and we really appreciate you taking some time out of your weekend to be here, and we really look forward to connecting with you further and coming out for a site visit or chatting on the phone about potential opportunities to talk things through. So thank you again so much for showing up today, and now we can open it up to questions, and Katrinka and I can stay a while even as we approach noon now. So thank you.